All right, in this video, we're going to be talking about distance versus time graphs, but we're going to be talking about a changing velocity. So in the past, we've been talking about constant motion, and now we're going to be talking about a changing motion. So just a refresher before we get started, if we're talking about a changing velocity, we're really talking about acceleration. So remember, acceleration can be an increase in velocity, a decrease in velocity, or if you're changing direction. So on all these graphs, we are not talking about constant motion. Somehow the motion is changing. Maybe the object or a car is increasing in speed over time or decreasing in speed over time. So our graphs are going to look a little bit different than before. So for these distance versus time graphs, we've already talked about constant motion. We've talked about if an object has a zero speed, what it looks like, if an object has a constant speed, whether that be positive or negative. But now we're going to be talking about positive and negative acceleration. We don't really use the term deceleration, but acceleration, because it's a vector, it has a magnitude and direction, we talk about it being positive and negative. Positive acceleration means that the object is speeding up. Negative acceleration means that the object is slowing down for these distance versus time graphs. So before we talked about constant motion, and we talked about on a graph that no movement would look like our pink line, that a constant speed to the right would look like our purple line, and a constant speed to the left would look like our green line. Remember, we always used straight lines. However, now our line's are going to be looking curved. So the curved segments on these distance versus time graphs mean that the object's speed is changing. So now we have curved lines because the speed is changing. So in this first graph, we have position versus time, or distance versus time. So as you can see, the slope of this first segment is a very shallow slope. There's hardly any change. So maybe the speed is just slowly increasing. However, after maybe 7 seconds or so, the speed increases, the slope gets steeper. So remember we talked about the slope of a distance versus time graph does tell us speed. So this is a very slow change in speed. This is a very drastic change in speed. So we're going from a slower speed to a faster speed. So that means that we are increasing in speed. So we're speeding up and it's in the positive direction. So for example, the object speed changes from maybe 1 meter per second, 3 meters per second, to 7 meters per second. So the object is moving towards the positive direction because we have this positive slope where we're moving towards the positive portion of the graph. So maybe the object's moving to the right, or it could be north. All right. The opposite, we now have a negative slope of the graph. Remember, that just means position-wise, we're moving towards the negative portion of the graph. So maybe the object's moving to the left or moving south. However, notice how this is just the complete opposite. It's inverted. So at first on the graph, this object has a very shallow slope. So again, moving slower, a slow change in the speed. Then, after a certain amount of time, the speed increases because our slope gets steeper. So we're still going from slow to fast, the direction just changed. So technically we are still speeding up, but now we're speeding up going toward the negative direction. So the object's speed changes from 1 meter per second, 3 meters per second, to 7 meters per second. We're still increasing in speed. However, the object is moving towards the negative direction. We have that negative slope. So maybe the object's moving to the left or south. All right, so the opposite of speeding up would be slowing down, and that is usually noted by negative acceleration. So I have this short video to play for you. All right, so in this simulation, we have an object that at first is moving with a constant motion. It's making the same distance every second, but then as you can see, it slows down and then it stops. So on each of these graphs, our position versus time graph, you can see that there is a curved line because our speed is changing. The object is slowing down. You can also see on the velocity versus time graph, because we're slowing down, maybe the object's moving at 20 meters per second at first and then it slows down to 0. And then for our acceleration, it's in the negative direction. So here our acceleration is maybe a -1 meters per second squared. So we're going to be talking about negative acceleration next. So again, curved lines, but now our objects are slowing down. So if we look at the slope of this line, we'll notice that at first the object appears to be moving at a steep slope, meaning it's fast. There's some sort of fast speed going on. So you launch the object, it's moving fast, and then the speed starts slowing down. Our slope kind of levels out to be more shallow, so it moves slower. So if we're going from fast to slow, our object is of course slowing down. And the object is traveling in the positive direction because we have this positive slope of our graph where our object is moving to the right. So the object speed changes from maybe 7 meters per second to 5 meters per second to 1 meter per second. The object is moving towards the positive direction, so the object's moving to the right or north. All right. Now looking at this graph, as we can see, the object first has this very steep slope. So again, meaning a fast speed. Then it kind of levels out. The slope is much shallower, so it's slower. So if we're going from fast to slow again, that means that we are also slowing down in this scenario. But we are now traveling in the negative direction. So we have this negative slope. The object's moving to the left. So in this scenario, the object speed changes from 7 meters per second, 5 meters per second, to 1 meter per second. So as you can see, we are slowing down. The object is moving in the negative direction, so this could be to the left or south. All right, so in summary, we're going to put together all forms of the distance versus time graph. So remember we have distance on our y-axis because that's what we're measuring. It's our dependent variable. We have time on our x-axis because that's our independent variable. It's something that we're changing, we're allowing time to go by. So our first line is going to be a horizontal line representing no movement. So that horizontal line could be anywhere on the graph. Now, if we're talking about a positive slope that has a constant speed, so that could be the object moving to the right, it would look like this. A negative slope with a straight line, that means that the object has a constant speed to the left, so that would look like this green line. All right, now when we're talking about positive acceleration, that means that the object is speeding up. So speeding up means it's going from slow to fast, so it could look like this blue line, or it could look like this blue line. Either way, we're going from a very shallow slope to a steep slope. So both of these curvatures represent positive acceleration. And then negative acceleration. The object is slowing down. Slowing down, so at first it must have some sort of steep slope, a fast slope. Then it slows down to a slower speed. So it could be like this. As you can see, it's steeper, faster. Then it kind of shallows out, so the object is slowing down. So it could look like that, or it could look like this. You have a steep slope at first where the object is moving fast, and then it kind of shallows out, so the object is slowing down. So, in summary, with these distance versus time graphs, if you were talking about a constant motion, so any of these, it is always some sort of straight line. However, our new ones, our positive and negative acceleration, those are all curved lines. All right, thanks for watching. That concludes our acceleration on distance versus time graph. If you have a question, thanks for watching.